So we are starting our chapter on linear. We're doing little parts of it. That's why the homework is kind of all over the place. I know that you've got 1,000 things going on this week. I know that you're finishing papers. You probably got a test in another class and all sorts of things. So as I say this, I know that you may not be in a position that you can do it. But if you can do this homework this week, you're going to be better off because that's what we're talking about. Typically, students remember the linear relationships more so than they remember factoring and more so than they remember the quadratics and the rationals. The linear stuff seems to click quicker for most students. And it's likely that as you're listening to what I'm saying today, you'll be like, ooh, I remember that. Ooh, I remember that. Ooh, I remember that. If you don't, that's okay too. But that's typically what happens. And typically students do pretty well on this aspect of it. The danger is going to be that we come back after spring break, we start chapter 6, and then all of a sudden you see a test with questions and you're like, where did that come from? That was like ages ago. And so I will do a review and remind you that this is part of that next test also. Okay, so there's the homework. So we are specifically going to talk about graphing lines first. And there's 3 different ways that you can graph lines. You can use a table of values. You can use the intercepts. And the most famous, the most straightforward, and probably one of the equations you remember from high school is y equals mx plus b. Y equals mx plus b is the most efficient way to graph the lines. You have to have an understanding of slope before we can do y equals mx plus b. But that typically is the thing that you use when you're graphing. Now, one of the things that I want to make sure that we're starting to think about, here is my x and y axis. Okay, my x-axis is the first part of my ordered pair, and my y-axis is the second part of my ordered pair. So we will need to remember that when we are graphing. A line is made up of points. How many points are on a line? How many points are on a line? Infinite. Infinite. Okay? That line keeps going forever in both directions. So for every single value of x, doesn't matter if it's negative, it doesn't matter if it's positive, it doesn't matter if it's a fraction or a decimal. For every single value of x, there is a corresponding y value. Always. Okay? So our lines do have an infinite number of points on them. Okay. Now, here, what we're going to do is we are going to graph this line using a table of values. So what I want you to do right now, and I want you to get into the habit of creating your table of values, we are going to have x points. Then we are going to do y equals x plus 2. We're going to have a corresponding y, and then we're going to have an ordered pair. Okay? So this is our table of values. Now, it's a good idea to get into the habit of always having some negative values that you pick. So I'm going to do -2, -1. I always do 0. Any graph that I ever do, whether it's linear, quadratic, anything, I always pick x equals 0 because that gives me the y-intercept. So I always pick x equals 0. And then I'm going to do 1 and 2. So I'm going to do the first one, and then I'm going to let you do the rest. So what I'm going to do is I'm going to take that -2, and I'm going to put it in for x. Okay? Because that's my first point. So I have y equals -2 plus 2. What is -2 plus 2? 0. So my y value is 0. And so then my ordered pair that I am eventually going to graph is negative 2, 0. The negative 2 is the x value that I randomly picked. I just picked that value. You can put anything in there for x. You may have picked negative 3 or negative 4. You can pick any value for x. You plug it in for that x, and then you get your y. Okay? So I'm going to give you about a minute to do that. So you're just going to plug in negative 1 and get the value, 0 and get the value. So now I am going to plug in negative 1. I have y equals negative 1 plus 2. What did you get? Positive 1. So what's my ordered pair there?
Negative 1 and 1.
You got it. Negative 1 and 1. Okay, for 0, I've got y equals 0 plus 2. So what's my y value? 2. And what's my ordered pair? Excellent. Okay, now I'm going to plug in 1. So I have 1 plus 2, which is?
3.
Good. So my ordered pair is?
1 and 3.
You got it. And then our last one, hopefully we got 4, and my ordered pair is 2, 4. Now I'm hoping that you see a pattern. What is happening at the y value? What is happening for each y value? Say that again. They are in numerical order. I heard it's increasing. It's increasing by how much? 1. That's what's going to happen with the slope. When we start looking at slope, you're going to realize that 1 that we see between these points, that's going to be related back to our slope. Okay? So now, one of the things that sometimes students forget is that they have to do the left to right first. So when I am plotting this point right here, negative 2, 0, I go over negative 2 first, and then I go up or down. Okay? That's one of the things that sometimes we forget. Okay? Students are like, I don't remember if I go up and down first or if I go left or right first. When I am plotting ordered pairs, we go left to right first, then I go up and down. So for negative 2, 0, I go negative 2. How much up or down do I go? None. So I'm going to put my point right there. That's where my point is. Okay? So that is my first point. Now I've got negative 1, 1. Negative 1, 1. So I go over negative 1, and then I go up 1. So that's my point right there. Okay, my next one is 0, 2. Then I have 1, 3, and 2, 4. And that is my line. Okay? And so you are graphing this line using a table of values. Now, does anyone know what this right here is called? This right here?
The x-intercept?
The x-intercept, okay? So that is where this line crosses the x-axis. What is this one called? Y-intercept. That's where this line crosses the y-axis. And that's going to be important for our next way that we can graph lines. So this is my x-intercept, and this is my y-intercept. Okay? When my line, and that is this right here, this is the x-intercept, and this is the y-intercept. So, when my line crosses the x-axis, what do you notice about the y value? So this point right here is where I'm crossing the x-axis. What is my y value? What's 0, okay? This is my x value, this is my y value. So when I have my x-intercept, my y value is 0. Y value is 0. That's going to be important. Y value is 0. Now, look at the y-intercept. Here's the y-intercept right here. Okay? This is my x, this is my y. What's my x value here? 0. So when my line crosses the y-axis, my x value is 0. Okay? Okay. So, now we are going to graph using intercepts. We are going to graph using intercepts. And we just talked about when I'm looking for my x-intercept, my y value is what? 0. And when I'm looking for my y-intercept, my x value is what? 0. Okay, so to find my x-intercept, I am going to plug 0 in for y. Okay? To find my x-intercept, I am going to plug 0 in for y. So, I have 3x minus 2, and what am I going to put in for y?
0.
Good. Equals 12. What's 2 times 0? Good. So then I'm left with 3x equals 12. I divide by 3, and what is my x value? 4. Now, this is a common mistake. A lot of times, students will take that x value that they get for their x-intercept, then they'll take that value they get for their y-intercept, and they'll put it together for one point. That's not how it works, okay? We have found our first point. What is the first point? 4, comma, what's our y value? 0, okay? So a point on this line is 4, comma, 0, okay? Because we plugged 0 in for that y value. We chose the y value. The y value we chose was 0. So this is a point on the line. Now, for me to do my y-intercept, I am going to plug 0 in for x. Okay? So I have 3 times 0 minus 2y equals 12. What's 3 times 0? 0. What do you think students forget?
The y at the negative stays with the 2y.
Good. Students forget all the time that that negative stays with that 2y. Don't drop the negative. Be careful with that. Don't drop that negative. Yes, ma'am?
Find the x-intercept and then plug that into the y. Like, is that?
You are not...
Just checking.
Okay, I gotcha. Okay, so this is step one. Okay, so it doesn't matter what we get here. For this second part, it doesn't relate to that. So this is part A and this is part B. Part B is we're plugging 0 in for X. Part A is we plugged 0 in for Y. Okay, so we are finding two distinct points. Okay, now I'm going to divide by -2. So don't lose your negative. So what is my y-intercept? -6. But remember, we're talking about a point on the line. We're talking about a point on the line. So that's an ordered pair. And my ordered pair is 0, -6. Okay? So when we graph this, okay, I've got 4, 0, which is right here, and then I've got 0, -6. 1, 2, 3. Okay? So there is my line. So, a common mistake. The problem will say, what are the intercepts of the line? And students will be like, okay, x equals 4, y equals -6. And then they'll write the answer as 4, -6. That's wrong. Okay? 4, -6 isn't even on this line. Okay? So this is the wrong way to do it. You do not do it this way. You do not take those two values and put them together. These are two very distinct points. One point is 4, 0, and one point is 4, -6. So two very distinct points. Okay? Okay. So we talked about graphing by a table, and this is how we graph by an x and y intercept. Now we're going to talk about y equals mx plus b. Okay? Y equals mx plus b is the most famous, and it's what we use the most often. Okay? Y equals mx plus b. Yes, ma'am?
So for the answer for the intercepts, is it just 4, 0, and 0, -6?
So if you were asked to graph it using the intercepts, then the graph would be your answer. Okay? If you are asked what are your intercepts, 4, 0 is acceptable. 0, -6 is acceptable. If you just wrote x equals 4 and y equals -6, I would accept that because you're being asked specifically to find the intercepts. And so x equals 4 and y equals -6 is correct. The only thing that's not correct is when you put those two together like we had right here. That's what would not be correct. So you have to really look at what the problem's asking, whether it's asking you to graph using intercepts or to identify the intercepts. That would be the two different things. This is the graph of the intercepts. This is identifying the intercepts.
So both of those would be accepted. If you're identifying, it could be 0, -6, or -6.
Yes. Yes, ma'am. Yes. Both of these are acceptable for me. Depending on if you take 144 next, just make sure. I don't know that you even talk about this in 144. Okay. Now, one of the things when we talk about y equals mx plus b is we have to understand that we've got two special situations with lines. Okay, and this is also going to come up when we start talking about slope. Y equals -3 and x equals -3 are special lines. One of them is a function and one of them is not a function. But we need to know what we're talking about. So when I've got y equals -3, that means every single one of my y values is -3. Every single one of them. So if I did a table of values for y equals -3, so this is x and this is y, -3 would be on every single one of them, okay? And I could put anything for x, because it doesn't matter, okay? I could put -1, I could put 0, I could put 1,000, that's 100, but I could put 1,000. I need a little bit more room for my zeros. Doesn't matter. My y values are always -3. So when I graph this, I am graphing, there's my y-intercept, which is -3, and every other value on this line is -3. So what kind of line is this? Is that horizontal or vertical? It's horizontal because it's horizon. Horizon. Okay? So y equals anything, y equals a number, you are going to end up with a horizontal line. This is a function. My horizontal lines are functions. X equals -3 means that every single one of my x values is -3. Okay? So it doesn't matter what my y value is. It doesn't matter what my y value is. Okay? It can be -1. It can be 0. It can be 100. It can be 1,000. Okay? But my x values are always -3. So here's my x-intercept right here. But all the rest of them are -3. What's my y-intercept here? For this line I just drew, what's my y-intercept? Where does it cross the y-axis?
Nowhere.
Nowhere, okay? When you've got a vertical line, you don't have a y-intercept. Okay? It's parallel to the y-axis.
And the same with x, if you don't have.
Correct. So on this one right here, you don't have an x-intercept. Good. Good, good, good. Okay? So these come up, especially in a few minutes when we start talking about slope again. This will come up. Okay, can I move to the next screen? Okay, so now we've got y equals mx plus b. Y equals -x plus 4. Y equals -x plus 4. So we are using the y equals mx plus b format. And so we need to understand what each part of this line represents. So, first thing, anyone know what b represents?
Y-intercept.
Yes, it represents the y-intercept. That is where my line is going to cross the y-axis. That is my y-intercept. N is my slope. That is my rise over my run. Okay? Slope goes up and down, then left to right. Up and down, and then left to right. Now, X and Y are ordered pairs, and they are constantly changing. Okay? The X and the Y have infinitely many combinations. They are points on the line. Okay? The x and the y in here. So when you are writing an equation for the line, when you're writing the equation for this line, you keep x and y in it. X and y stay x and y because they represent all the different ordered pairs. They represent all the values in that table of values that we can put in. Okay, so B is our y-intercept, M is our slope. So in this particular problem that I have right here, I've got y equals negative x. I do not know how to draw a straight line. Okay? In this problem right here, 4 is my y-intercept. My intercept is the constant. It's the number that is not with my x. Okay? It's the number that stands alone. It's the constant. So I'm going to put, there's my y-intercept right there. It's where I cross the y-axis. So I'm going to write that down. My y-intercept is where line crosses y-axis. Now, students typically do okay with this, but if they do make a mistake, it's because they put it on the x-axis. Okay? So, you need to understand B is your y-intercept, and that's where the line crosses the y-axis. Okay? Now, what number is in front of that x? A negative 1. Negative 1. So it may be helpful to you to write that 1 right there. Okay? Then I need to identify that as a fraction. Okay? I've got to have a rise over a run. So if I've got an integer, and an integer can be positive or negative, then I just put that over 1. So if I've got the number 2 in front of the x, it's 2 over 1. If I've got the number negative 3, it's negative 3 over 1. Okay? So you have to think of your slope as a fraction. And if you're not given a fraction, remember that all numbers can be written over 1. So my slope here is negative 1 over 1. Now, slope is rise over run. Rise means up and down. So I'm going to go up and down first. Then I'm going to go right to left. Up, down, right, left. Which way do I go for negative 1? Do I go up or do I go down? Down. Good. Okay? So I'm going to go down negative 1. Okay? What color is easier for you guys to see? Let me see if that's better. Yeah, that's better. Okay, so I went down negative 1. Now, my numerator, is that positive or negative? Positive. So I go to the right 1. Okay? What happens here is students account for the negative twice. And what's a negative over a negative? Positive. So only account for the negative 1 time. So we go down 1, that's the negative 1, then the positive 1 is to the right. Now we can do this as many times as we want to draw our line. Okay? Okay. This is probably the form of graphing that you remember. It's probably the form of graphing that you remember. Now, what happens, though, when it's not in y equals mx plus b format. What if I have 3x minus 2y equals 12? So I'm being asked to graph it using y equals mx plus b. But it's not in y equals mx plus b format. So what do I do? Caitlin?
You want to figure out what the y would be first.
Okay, so how would I do that?
Subtract 3x on both sides.
Good. So what I have to do in this situation is I am going to solve for y. And we did this at the very beginning of the semester. On that first test, we had to solve for y. That first test, sometimes we had to solve for y. And we talked about how it was related back to this. We have to solve for y. Okay? So here I've got 3x minus 2y equals 12. So minus 3x. What do you think I'm in danger of forgetting? The negative. Okay, so bring that negative 2y down. Okay, now I'm going to divide everything by negative 2. So I end up with y equals 3 over 2x minus 6. Okay, so now we have our b value, which is our y-intercept. Then we have our slope. Okay? I start at negative 6. I don't ever go down far enough for negative 6. Okay. Okay, there's negative 6. My slope is rise over run. I go up 3 and over 2. Okay? Rise over run. Okay? And I can do that as many times as I want. So 1, 2, 3, 1, 2. Okay? So here's my line. Okay? Questions on y equals mx plus b. Questions on y equals mx plus b. Okay. Now we're going to talk a little bit about slope. We're going to talk a little bit about slope. Slope has all sorts of applications in life. How many of you guys know someone, or because of an injury, you've had to be in a wheelchair before? Or you have a friend or a parent or something like that. Okay? Slope plays an incredibly important role in the ramps, in wheelchair ramps. There is a maximum slope. There's only so many inches that a slope can rise over a horizontal period. Okay, and I think it's 1 to 12. So every 12 inches, the slope can only go up 1 inch. I think don't hold me to that 1 over 12, but I think that's what it is. We just recently had some work done on our house, and they had to put a roof line. And the guy was talking to me about pitch of the roof. But your pitch of your house roof or your apartment roof or your dorm roof, that's slope, and it has to meet federal guidelines. And there's a couple of different options depending on what you're doing with that. Okay? Slope is also the rate of change. The rate of change. So sometimes you are looking at an increase in sales, and that's a linear relationship. If you're going into anything with business, you're going to have some linear relationships, or they're going to use linear models to predict relationships. Okay, and so on Friday, we will talk some about some word problems associated with slope and linear relationships. And so slope is used a lot, okay, and it's definitely used to do some prediction factors, predicting. So what we're going to do now is we are going to find the slope between 2 points. And before we talk about that, I want you to think about some of the real-world examples for different kinds of slope. So we have 4 options with slope, and we're going to see all of them when we do that. But I kind of want you to think about, here's our coordinate plane. So what we run into the most is a positive slope that looks like that. Okay? That means in the stock market we are earning money. Okay? If we have a new baby, that baby is gaining weight. Okay? If we are predicting a sales, and these are our sales pattern, our sales have increased. Our home value has increased. Okay? This is a positive slope. Okay? The next one that we talk a lot about is a negative slope. This is what we see the most. Positive and negative slopes. Okay? A positive slope can be represented by a positive number over a positive number, or, like in the one that we just saw, it can be represented by a negative number over another negative number. A negative and a negative makes it what? Positive, okay? So be careful here. Be careful. Sometimes with negative slopes, students account for that negative part twice, and they've turned it into a positive slope because they're so scared of not accounting for the negative, they over-account for the negative, and then they have a positive number. Okay? Now, our negative slope is when we are losing weight. Okay? What happens as soon as you buy a car? If you buy a brand new car at Mercedes, I don't recommend it, and you drive that car off the lot, it loses value like that. It's not even linear. It happens so fast, it's like an exponential. Okay? But you see a drop in value. Okay? In 2008, I think in Alabama, we lived in Atlanta in 2008 or 2007, and the housing market crashed. And the value of houses went down. Okay? So unless you're losing weight, sometimes we don't like this one. I'm trying to think of another good one that, the slope of my roof has a slope like this, so that's good.
Infant mortality.
Infant mortality, we want that to go down. Yeah, so there's some good stuff for this one as well. For a negative slope, you can have a negative number over a positive number, or a positive number over a negative number. Okay, it doesn't matter. It doesn't matter. As long as you account for the negative in one of the spots, you're fine. Just don't account for it twice. And make sure the slope of that, this is what a negative slope looks like. We talked about a horizontal line, and a horizontal line is a function, and a horizontal line has a slope of 0. Okay? And sometimes we want the change. We were incredibly fortunate. We lost a ton of money on our house in Atlanta, but then when we moved to Denver, our house value didn't drop. For like 6 years, it stayed exactly for what we bought it for. Okay? So if the stock market or the housing market has crashed, and your stock or your house stays the same, then that's a good thing. So there are times when this is steady. If you like your weight and you maintain a zero slope, then that's a good thing. Okay? So, but if your money's in the stock market, you want it to go up. But this is way better than it going down. Okay? So this is when we have no slope. And what this means is there's no change. There's no change. Okay? Everything is staying the same. It is steady. It is steady. It is only represented by a 0 in the numerator. Okay? Your 0 in this scenario is in the numerator only. Numerator. 0 divided by -12 is 0. And that is okay. So we have a 0 slope. The last slope is what confuses students. And it is the slope of a vertical line. Okay? A slope of a vertical line is undefined. It is not possible. Okay? So if you have a slope that is undefined, you're talking about a vertical line. And the way that I talk to students about that, if we are following our money in the stock market, or we're following the value of our house, what happens is this represents time stopping. Can time stop? No. So this would mean there's a huge jump in your money or there's a huge decline in your money and time has stopped. Okay? That's what an undefined slope represents. And there's a lot of things that stop, but time isn't one of them. So an undefined slope is when all of your x values are the same. And what we get is we get something like 12 over 0 or -3 over 0. Your 0 is in the denominator. And that is not allowed. Okay? That is not allowed. So, if you have a 0 in the numerator, you're good. Your slope is just 0. If I have a 0 in the denominator, my slope is undefined. My slope is undefined. Okay? Sometimes students represent that with a 0 with a line through it. And sometimes students just write undefined. Okay? 0 and undefined are not the same thing. 0 and undefined are not the same thing. Okay. So, I've got a couple questions over here on slope. This particular one is my favorite. Okay? The triangle means the word change in. Okay? Change in. So for slope, we are looking at the change in y over the change in x. Okay? Change in y over the change in x. Students tend to like this one the best. Okay? So what this means is I'm taking my y values and I'm subtracting. Then I'm taking my x values and subtracting. Okay? So for this one, I am going to start with this point right here. 3 over 2. So I've got to start with my y value first. So I am going to have 2 minus 1. Now, because I started with this point for my y value, I have to start with that point for my x value. I can't switch that. Okay? So then I have 3 minus negative 1. 3 minus negative 1. Okay? Minus a negative becomes plus. 2 minus 1 is 1. 3 plus 1 is 4. Okay? Now, if I did it and I started with this point, I would get exactly the same thing. Okay? So now I'm going to do 1 minus 2. So I've done 1 minus 2. Negative 1 minus 3. So then I get 1 minus 2, that's negative 1. Negative 1 minus 3 is negative 4. What's negative 1 over negative 4? What is it? Positive. So it's positive 1/4. So do I get the same thing? The important part is whichever point you start with for the y, you've got to start with that same point for your x. If students make mistakes, that's where it is. Okay? So is this a positive slope or a negative slope? Positive. My money or my house or my baby's weight is going up. My sales are increasing. Okay, let's do the next one. So I've got change in y over change in x. I'm going to start with this point right here. So I've got 5 minus negative 2. Then I've got negative 1 minus 4. 5 minus negative 2 becomes positive. Negative 1 minus 4 is negative 5. Okay? So if you can get negative 7 over 5, you can get 7 over negative 5, or you can write it negative 7 over 5. And all those are fine. You can have the negative sign in the denominator, the numerator, or right in front of it. What's the one thing you can't have? You can't have the negative sign on top and bottom. Okay? So if you put the negative sign for this problem on the top and the bottom, then that would be wrong because you've turned a negative slope into what? A positive slope. Okay? So be careful with that. Now, I want you to do the next two. I want you to do both of these. Okay? I'm going to give you about, well, whoops, never mind. Okay. So what happens here is I do negative 3 minus negative 3. And what do I get? What do I get in the numerator? 0. Okay? So this is going to be 0 over negative 5. What kind of line is this? No slope. Okay? This is a 0 slope. Here, I'm going to get 0 in the denominator. So this one is undefined. This is undefined. Okay?